All right, so on the free response review for Unit 5, we're talking about cereal boxes. A box of Raspberry Crunch contains a mean of 13 ounces, standard deviation of a half an ounce. It's approximately normal, so the probability that a case of 12 cereal boxes contains more than 160 ounces. So I put my mean and my standard deviation here, and but since it's a case of 12, that's redundant. The mean of the case should be 12 times 13, 156 ounces. And since we have a sample, then we have to find a new standard deviation. So I multiplied 0.5 times 12 divided by the square root of 12. So that's 6 divided by the square root of 12. My new standard deviation is 1.73 ounces. So since it tells me up here it's approximately normal, I do a normal model. My mean's 156. There's my standard deviation, my new standard deviation for my sample. So I started listing out here, and I went 2 standard deviations because we know that anything outside of 2 standard deviations we consider unusual. Other teachers may not teach it that way, but for this class, we consider that unusual. So here's approximately is where 160 ounces would be. So we're looking from this point to the right for 160 ounces. We're looking that point to the right for 160 ounces. That's what's covered in that area. So we do a normal CDF. To find the probability that X is greater than 160, we're going to do a normal CDF. So with that normal CDF goes second distribution number 2. All right, and so we're going to go from 160 to 200, okay, because we're just making some number up out there. You could go to infinity or wherever. And then we put in our mean is 156. Our standard deviation is 1.73. And this is what it looks like. Now, we need to go ahead and make this statement. This is my lower value because that's the lowest value that we're looking at because it says a total more than 160. So 160 to 200 with a mean of 156 ounces and a standard deviation of 173 ounces gives me the decimal 0.010384, which I rounded to 0.0104 or about 1.04%. So about 1% of the time, we would expect 12 cereal boxes to have more than 160 ounces, about 1% of the time. Okay. Then question 2 is we have a random sample of men and women, and we found that 88 of the men exercise regularly and 130 of the women exercise regularly. And they want us to create a confidence interval for the difference in the proportion of men and women who exercise regularly. Now, notice I said men and women. They say women and men. It doesn't matter, but you just need to make sure that in the end run that your numbers match up with how it should look. So here we go. We're going to start out with, here's my men. M is for men, W is for women. So the X number of men was 88. The N was 150. XW for women is 130 who exercise regularly, 200 women. That makes P hat for the men 0.857 and Q hat is 0.413. For the women, P hat is 0.65 and Q hat is 0.35. And of course, my Z star, because we're doing a 95% confidence interval, Z star is 1.96. So then I look at my conditions. I have a random sample of men and women. 150 is less than 10% of all men. 200 is less than 10% of all women. I'd found my NP for the men is 88 and 62. They're both greater than or equal to 10. Did the same for the women, 130 and 70, success and failures, that's greater than or equal to 10. We have independent groups to run a 2 proportion Z interval. 2 proportion Z interval. So we got to find 2 things. Okay, first thing we're going to look at is the confidence intervals formula. I know I named it over here, but I showed it here. I'm doing the P hat of men minus the P hat of women. You can do that vice versa. Plus or minus Z star times the standard error. Well, we have to find the standard error. We have this, we have this, we have that. We got to find that. So to find the standard error of a pooled group here, we've got 0.587, 0.413 over 150, plus 0.65, 0.35 over 200. This is the men's group. That's the women's group. We find the sum of those two, and we divide by, we find the square root. That gives me the interval of a negative 0.166, and a positive 0.04. Now, so if we go stat and over to test, and we're doing a 2 proportion Z interval, a 2 proportion Z interval. So we need to go up to B is a 2 proportion Z interval. Okay, there's our numbers already put in there. 88 for the men out of 150, 130 for the women out of 200. Now, if you had this backwards, not backwards, but if you had it different, if you put the women first and then the men, that's fine, ladies first. But make sure this is 0.95, and then we work the problem. Let me rephrase. We let the calculator work the problem. So there is my interval, negative 0.1662, 0.03952. So I've rounded each of those to these two numbers. Notice what I did not do. Notice, ladies and guys, I didn't put numbers in here because I know that's my formula. I put numbers here, but I did not do the calculations. I don't want to round something and be counted off wrong. I don't want to have something happen and me do something wrong. Okay, remember for standard error, we want to put the hats in there, P hats and Q hats in this case when we're comparing two groups. So now what does this mean? Well, that means this. We are 95% confident that the proportion of men who exercise regularly is between 16.6% lower because it's a negative and 4% higher because it's a positive than women who exercise regularly. That's our interval for our sample. Okay, and so then part B says, a friend says that she believes women exercise more than men. They have a higher proportion. They have a higher proportion than of women that exercise regularly as opposed to men. So does your confidence interval support this conclusion? Well, mine does not because there is a zero in there. My interval contains zero. So I cannot agree that a higher proportion of women exercise regularly than men. Okay? In context, there's a zero there. There's not enough proof there for me to believe that. All right, so make sure on the test that's going to be Friday that information, conditions, calculations, conclusions. And then if there's an extra one, make sure you answer it in context. Okay, then let's see, what is the next question? Next question is, internet access. So we're finding a confidence interval here. This is question 14. 28% of U.S. teens, whoops, you can't see that. There we go. Let's start over. 28% of U.S. teens, 13 to 17, have computer access with internet in the room. Duh. It's a lot more than that now. This was in a long time ago. The poll was based on a random sample of 1,028 teens and recorded a margin of error plus or minus 3%. What level of confidence did Gallup use for this poll? So we're solving for Z star. So here we go. We've got the measure of error. Our measure of error is equals Z star times the standard error. So we have P hat and Q hat. That's these numbers come from our sample, and then N is 1,028. So my margin of error, it says plus or minus 3%. So I got plus or minus 0.03 equals Z, that's what we're trying to find, the standard error, which is this P hat, Q hat over N, the square root of. This answer is 0.04 when I punched it into my calculator. This is still 0.03. So we know to divide both sides by 0.014. And so I get a plus or minus 2.14. I get a plus or minus 2.14. Since we're doing this confidence interval, we know that they had that fits a normal model. I drew my normal model to show you exactly what we're trying to find. We're trying to find the area, what percent of the model falls between a negative 2.14 and a positive 2.14. Like if we were doing a 95% confidence interval, we know it falls between these two numbers, between plus or minus 1.96, but we're rounding to 2 and negative 2 standard deviations. In this case, we have these two numbers. And so to find that, again, we go to a normal CDF. I just showed you how to do that. This is my lower, this is my upper, my mean, and my standard deviation because it's just a simple normal model with Z-scores. And when I found this in the calculator, I got 0.9676 or about a 97% confidence interval. We're finding the area between these two numbers once we solve. Because this was plus or minus, we've got a positive and a negative that number. We put them on the model and say, okay, let's find the area in between those two numbers. Okay, then our last question is sleepy adults. Do more than 50% of U.S. adults feel they get enough sleep? So Gallup did a poll in 2004, and 55% of U.S. adults said they do. The poll was a random sample of 1,003 U.S. adults. So we're going to test an appropriate hypothesis. We're doing a z-test because we have percents, and state your conclusion in the context of the problem. So here we go. Oh, let me find that page. Here we go. All right, so on this problem, we've got that P is 0.5 and Q is 0.5. That's our null hypothesis. From our sample, with 1,003, our probability was 0.55, and the Q hat was 0.45, the percentage, the proportion. Sorry, I said probability. Now, 552 came from 0.55 times 1,003. It was a decimal that I rounded up. Alpha is 0.05, and here's my null hypothesis. Now, please, please, please put a colon there, not an equal sign. Null hypothesis is that P equals 0.5, and the alternative is that P is greater than 0.5. Okay, this is what we're testing. So did we have a random sample of U.S. adults? Yes. Is 103 less than 10% of all U.S. adults? Yes. Okay, now notice this is NP and NQ. I'm using P and Q on this. They would have, if these numbers were right, then I would have 501.5 and 501.5, which are both greater than or equal to 10. Again, College Board leaves those as decimals. I haven't been told to change that yet, so leave it as that, and we'll be happy. So now the conditions are met, we can do a one proportion z-test. To be able to do a z-test, we have to have standard deviation, which is the square root of PQ over N, okay, 0.5, 1,003, not P hat, Q hat. This is the standard deviation. This is P and Q. And we have to find a z-score, P hat minus P over standard deviation. Notice, ladies and guys, I didn't put an equal sign here. I don't have a number because I'm concerned that some of you will write a number in there and it will be wrong. But we can find this, and they know we're using a calculator. And so we go stat, go over to test, and we're doing a one proportion z-test. This is 5. Whoops, we need to change these numbers. So this is 0.5. This is 552. This is 1,003. And it's, go back to the alternative hypothesis, is greater than. And then we calculate. Okay, there's our z-score. So I rounded the z-score to 3.19. It's 3.189. So I rounded up to 3.19, which we know to be unusual. That's large. Now notice there's an e to the negative 4 here. That's a 7. We don't want a 7 there. Okay, we want a number less than 1. So we look over here. Oh, let's move that decimal 4 places to the left. Gives us this value. And I go ahead and tell them that's my p-value. I want them to see that. And so from there, we had our alpha. We compare the two. With a low p-value compared to alpha, we reject the null hypothesis. There is strong evidence. The proportion of U.S. adults, whoops, sorry, let me cover up that LY right there. There is strong evidence the proportion of U.S. adults who feel they get enough sleep is greater than 50%. Okay, so there's 13 and a half minutes of work. Hopefully it won't take you that long to watch the video. If you have any questions, let me know. Hope you have a great rest of the day.